Hello, this is Dr. Hanaa Assil, and today we're doing the exam for Unit 2 in IAS Chemistry. This was the exam that was offered in January 2022. So let's take a look at the questions and how to answer. So in the first section, we have multiple choice questions. So the first one is, which are correct for the reaction shown? So he gives you a reaction with a delta H that is negative, and he's asking, first of all, is it endothermic or exothermic? You have to remember that when delta H is a negative number, that means the reaction is exothermic. Now, what type of reaction is this? What type of enthalpy change is this? This is a reaction between an acid and a base to give salts plus water. So this is delta H of neutralization. The next question is saying which equation does not represent a standard enthalpy change of atomization. Now, we need to remember what is the standard enthalpy change of atomization. It is the enthalpy change that takes place when 1 mole of gaseous atoms is formed from its elements under standard conditions. So you're looking for an equation that should form 1 mole, that would be the standard enthalpy change of atomization. Now he's asking which one is not standard enthalpy change of atomization. The first one, it forms 1 mole of magnesium gaseous atoms, but the second one forms 2 moles of chlorine atoms. That's not standard enthalpy change of atomization. This next question says 5.2 grams of sodium hydrogen carbonate is added to an excess acid. The temperature increases and the energy change is calculated to be 1030 joules. What is the enthalpy change per mole? You should remember that the enthalpy change per mole should be Q over N. Now, I need to get N first. You know that the number of moles is the mass over molecular mass. So the mass is 5.2 over the molecular mass. Notice he already gives me the molecular mass. Please pay attention so you don't need to waste time and sit down and calculate it. And this gives a certain number of moles. Now, the delta H would be the energy change that he gives divided by the number of moles. Remember that delta H must have a sign, and if he says that the temperature increases, that means we're talking about an exothermic reaction, so my sign must be a negative sign. So the answer would be B. Okay, so this is the next question. The equation for complete combustion of methanol is shown. He gives you the bond enthalpy data, and he's saying, what is the bond enthalpy for the C double bond O in methanol? So remember, he's not telling you to calculate delta H. He already gives you the total overall delta H is minus 591 in the equation. And you're supposed to try and find out what is the bond enthalpy for the C double bond O in the methanol. So we calculate this. So the C double bond O plus, I have 2 CHs, so 2 times 413, plus the oxygen-oxygen bond, 498, minus the products. Remember, it's reactants minus the product, minus 2 bonds of C double bond O in CO2, minus 2 OH bonds. The overall of all of that should be minus 5921. So when you calculate, you get the value for the C double bond O in the methanol, and that comes out to be this number. Okay. Which sequence shows the molecules in order of increasing boiling temperature? Okay, what are the options that I have? I have water, bromine, chlorine, methane, and he puts them in different orders. So let us take a look at this. Now, methane is a molecule that has only weak van der Waals forces between it. Chlorine will also have weak van der Waals forces, but compared to bromine, chlorine must be less because we said bromine um, is a bigger molecule with more electrons, so stronger van der Waals forces. So if we're comparing chlorine to bromine, bromine would have higher boiling temperature. What about water? Well, we should know that water forms hydrogen bonds between the molecules, so that would be a higher boiling temperature than the others because the others only have van der Waals forces. So as we look at it, the smaller molecule will have the lower boiling temperature. So the order in this case would be the methane and then chlorine and then bromine and then the water because the hydrogen bond is the stronger of all of these interactions. Which is not correct about ice. So let us think about ice. What is ice? Ice is actually water in the, of course, in the solid state. And we said when water forms a solid state, this is the only substance that when it forms a solid, it is lower density. All the solids are usually higher density than its liquid, and the liquid is higher density than the gas. But when water solidifies, there are hydrogen bonds that keep the molecules away from each other. So actually ice has a lower density than water, so that is correct. He's looking for which one is not correct. Now he's saying water molecules are further apart in ice than in water. Yes, because we said there is hydrogen bonding as the molecules come nearer to each other to form ice. The molecules are held apart by the hydrogen bonding. Now the HOH bond angle is the same in ice and in water. Actually, it is not, because when they start to form hydrogen bonds, they come closer to each other or further away from each other, so the bond angle would be slightly different. The last choice we have is water molecules in ice are held together by hydrogen bonds. Yes, that is correct. Which intermolecular forces exist between molecules of the compound shown? Well, let us look at this molecule. What kind of intermolecular forces can we have? Remember that if I have an OH, then there is a permanent dipole because oxygen is more electronegative than hydrogen, so there is permanent dipole. So that is one interaction. Of course, all of these covalent compounds have weak London dispersion forces between them. So any of these molecules will have London dispersion or London forces. This one also has permanent dipole interactions. And since we have a hydrogen attached to an electronegative element, it also forms hydrogen bonds. So all these three are present between these molecules. This question is about alkanes. And he's saying which of these alkanes has the highest boiling temperature. Well, let us compare them. They're all alkanes, and they are all straight chain. He did not mention that they are branched. So butane is 4 carbons, hexane is 6 carbons, pentane is 5 carbons, propane is 3 carbons. Remember, which of these would have the highest boiling temperature? We said the one with the more number of carbons. Since all of them are alkanes, they will have only van der Waals forces between them. So the one that has more electrons in the molecule, more number of atoms, that will be the one that has the highest boiling temperature. So among all of this, hexane would have the highest boiling temperature. Now this one, he's saying which of these has the lowest boiling temperature. Remember, all of these, if you look at them, they have the same number of carbons. But if we said if we have a straight chain like in D, that would be highest boiling temperature. the lowest boiling temperature would be the one that has more branching. So A would have the lowest boiling temperature. It has more branches. That means the molecule is smaller, more compact, and it will have a weaker van der Waals force. Which solvent dissolves the greatest amount of hydrocarbon? Remember that a solvent would dissolve something that is similar to it. So this is a hydrocarbon. That means it has only van der Waals forces between the molecules. That means it would, and it's not polar, so it would dissolve something that is similar to it. Remember, solvents dissolve substances that are similar to them, or that can do, for example, hydrogen bonding with them. But here we have a hydrocarbon. It cannot do hydrogen bonding. So I am looking for another hydrocarbon that can dissolve in it. So butanol is an alcohol. An alcohol would want to dissolve in something that it can do hydrogen bonding with, like water. Ethanoic acid would also form hydrogen bonding with its solvent. Hexane is hydrocarbon, no hydrogen bonding, so that would be the most suitable one to dissolve this large C35H72. The next question says, which reagent would convert an alcohol into an alkene? Remember that you are required to know each of these reagents or each of these conditions. What do they do to the alcohol? So if we look at acidified potassium dichromate, you should know that acidified potassium dichromate is something that oxidizes the alcohol. So it would form the aldehyde or the acid, not the alkene. Now, which one forms alkene? You should remember that concentrated phosphoric acid is the one that would do what we call the hydration of alcohols to form alkenes. But the others, potassium dichromate would oxidize it. We said potassium dichromate is orange and it reacts with the alcohol and oxidizes it and becomes from orange to green. The alcoholic potassium hydroxide, ethanolic potassium hydroxide, it reacts with the halogenoalkane, not the alcohol. So if I had a halogenoalkane and I wanted to make an alkene from it, then I would use that last choice, ethanolic potassium hydroxide. But here, if we're starting with an alcohol, then it is a concentrated acid. Which name is correct for this ion? Of course, you should realize that this is sulfate. Sulfate with a sulfur that has what oxidation number? That's the numbers that are put there. 2, 4, 6, 8. So sulfur here has which oxidation number? You should realize that each oxygen has -2. I have 4 oxygens, so that is -8. Now I want the overall, notice, should be -2. So my sulfur here is actually a +6. So we call it sulfate 6. In which compound is the oxidation number of nitrogen +5? Do you know how to calculate oxidation number? Let's go through calculation of oxidation number. Calcium nitrate, for example. I want to know what is the oxidation number of nitrogen. So I have one calcium. Calcium is in group 2, so it must be +2. Now each oxygen is -2, and I have 6 of them, so that is -12. The overall for this neutral molecule is 0. So calculating for X, this is the one that will have X +5. But if I look at magnesium nitride, also trying to calculate it, magnesium is in group 2. I have 3 of them, so that is +6 plus the 2X for nitrogen should be overall 0. So in that case, nitrogen is -3. If you calculate it for N2O3, it is +3. For sodium nitrite, it is +3. So the one I'm looking for is calcium nitrate. Here he's saying in which reaction is the copper species acting as an oxidizing agent. Okay, what is an oxidizing agent? We said that is the substance that has been reduced. Reduced means it has gained electrons. So in which equation has the copper gained electrons? Well, that first one, the copper changed from 2 plus to 0. That means it has gained electrons. So in that case, the copper 2 plus has been reduced. So it is acting as an oxidizing agent. Now here he says two half equations for a reaction are shown. And he gives me two half equations and he's saying what is the overall ionic equation for this reaction. Now, let's review how we do that. Now, the first thing we need to do is do something to the equation so that the number of electrons in both equations should be the same. So what can I do to make the number of electrons the same? Well, I can multiply the first one by 3, all through by 3, multiply the second one all through by 2. So I have this kind of equation and this one. Now both of them have 6 electrons, so the electrons can be cancelled, and I write in the overall equation everything that is left before the arrow and everything that is left after the arrow. So this would be your overall ionic equation. So which one is this in the choices? It is C. Can you see that it is C? Okay. So that is how we do the overall ionic equation. Now, a titer of 13.25 centimeter cubed was obtained using a 50 centimeter cube burette. What is the percentage uncertainty in the titer? Remember that when we use a burette, we need to measure the initial volume and the final volume. Now, he's telling me already, and actually I should know, that each reading of a burette has an uncertainty of plus or minus 0.05 centimeter cubed. So this is the margin of error in each reading. Well, I'm going to read it twice, so that means that the error should be 2 times the 0.05, so it's 0.1. Now he's reading a volume of what? Of 13.25, so it is 0.1 over that volume times 100. And remember that the percentage uncertainty is plus or minus something, so that would be my answer. Here he's saying barium hydroxide reacts with sulfuric acid as shown. Which is the ionic equation for this reaction? Again, how do we write the ionic equation for something? Remember, we ionize whatever is aqueous, but we do not do anything to whatever is solid, liquid, or gas. So let us try and ionize this. Now I have barium hydroxide is aqueous, sulfuric acid is aqueous, so I can ionize each of them. Can you see how we ionize it? But the barium sulfate is a solid. It remains as it is. The water is a liquid. It remains as it is. So that means that that first question is my first choice is my answer for this. 4 tests used to identify ions are shown. Which tests could be used to positively identify the ions in ammonium chloride? Well, that means I need a test for ammonium and I need a test for chloride. So what choices do I have? He's giving me flame tests. Flame tests are tests for what? These are tests for metal ions. I don't have any metal ions, so I'm not going to use flame tests. The second choice is addition of acidified barium nitrate solution. Again, this is a test for what? This is a test for sulfate. I don't have a sulfate. I don't need to test for that. Now, test 3 says addition of acidified silver nitrate. Well, silver nitrate is a test for chloride, so I will need this test to test for chloride. Addition of sodium hydroxide, then testing any gas with indicator paper. That is the test for ammonium. So that means I will need tests 3 and 4. Which conditions give the highest yield for the forward reaction? So he wants the forward reaction, and he already tells me that delta H is positive. That means the forward reaction is endothermic. So should the temperature be high or low in order to go endothermic? I should choose a high temperature. Remember, increasing the temperature goes endo. So I want to go forward. I need a high temperature. So what about pressure? Well, pressure is determined by where I have more number of moles or less number of moles. So you should know that if I use high pressure, it goes to the side with less number of moles. But here I wanted to go forward. Forward gives 2 moles while backward gives 1. So actually I need a low pressure to cause the reaction to go forward, to give, in this case, to give more number of moles. Nitrogen dioxide and dinitrogen tetroxide exist in equilibrium. When an equilibrium is set up in a gas syringe, the mixture is pale brown. So he's saying that originally it is pale brown. Now, when the mixture is compressed, what happens to the color? Well, you should remember that immediately, as soon as I compress it, the substances or the molecules come closer to each other, and that means that the color will become darker, and then it will go, this is increasing pressure, and that means it will go to the side that is less number of moles. So actually it will go forward, so the color will then become lighter. Do we understand that? When we increase the pressure, we're pressing the molecules. When it is brown, that means I have NO2. And if I'm pressing the increasing the pressure, that means the molecules of NO2 first will come closer, so you'll have a darker brown, but then the equilibrium will shift forward to give less number of moles, so the color will become light. So in section 2, you have this question: ammonia reacts with 1-chlorobutane. State the type and mechanism of this reaction. We said if we have ammonia, ammonia is something that has a lone pair of electrons. You are reacting it with a halogenoalkane. That means I'm going to try to replace the chlorine or the chloride with ammonia. That is a nucleophilic substitution reaction. And then he says, a student drew the first step of the mechanism. Now identify 2 omissions in the student's mechanism. What is wrong about the student's mechanism? Remember we said, first of all, we need dipoles. He doesn't have the positive dipole on the carbon. And the nitrogen attacks with its lone pair of electrons. So he's supposed to put a lone pair of electrons on the nitrogen. To obtain butyl amine, sodium hydroxide solution is added. So once we have replaced the chlorine with ammonia, now I need to form the amine. The amine is something that has NH2, not NH3. So we need to add sodium hydroxide solution. How will this remove the extra hydrogen? You should realize that the OH minus from the hydroxide attacks the hydrogen, and the electrons of the bond go to the N positive. It ends up with the amine, the one that has NH2 at the end is an amine, plus what? We have removed the H with the OH minus, so now we're forming water. Then he's saying the reactions of ammonia and of hydroxide ions with halogenoalkanes are similar. Compare the rate of reaction of ammonia with 1-chlorobutane and with 2-bromo-2-methyl propane. Okay, let's take a look. What do these molecules look like? This is 1-chlorobutane. Now 2-bromo-2-methyl propane, that's this one. So he's saying compare the rate of reaction of ammonia with the 1-chloro and with the 2-bromo. So basically we're trying to break the CCl bond and the CBr bond, and he wants to know which one is faster. You should realize that the rate of reaction with the 1-chloro will be slower. because the CCl bond has higher bond enthalpy, so it is more difficult to break. And you should notice that the 1-chloro is a primary halogenoalkane, while the 2-bromo-2-methyl is a tertiary, and we said the tertiary react faster. This question says enthalpy changes of combustion can be determined using calorimetry or calculated using Hess's cycle. Now he has a sample of 2-methyl propane 2-ol, so that's an alcohol. It was burned in a spirit burner and used to heat 75 grams of water. And he gives you a table. What is the mass of the spirit burner? At the start it was this, and at the end it was this. So the difference is the mass of the spirit burner. Now the temperature at the start it was 19.5, at the end 65.3, so the difference is this temperature. Now he's saying calculate the enthalpy change of combustion of 2-methyl propane 2-ol, give a sign and unit. So we're trying to get delta H. Okay, how do we get delta H? First of all, we need to get Q. You should know that Q is MC delta T. What is M? M is the mass of water or mass of solution. So he gives you that the solution is 75 grams. So that is the mass that you're going to use, times the C, 4.18, he already gives it to you. The change in temperature, we got it from the table, and the result from this equation is in joules. If I want it in kilojoules, I divide by 1,000. So that is Q. Now we need delta H. Delta H is Q over N. Now, how do we get N? N is the mass over the molecular mass. He gives me a certain mass of the 2-methyl propane 2-ol, and I need to calculate the MR. So the MR of this compound is 74 from normal calculation. So the number of moles would be the mass he gives me, which was 0.57 over the MR I calculated. So this is the number of moles. Now calculate delta H, and please remember delta H must have a sign. Here he says the temperature went up, it increased, and that means it is exothermic, and that means the delta H must be a negative number. Don't forget to write the units. Of course, we used kilojoules, so now it is kilojoules per mole. The standard enthalpy change of combustion can be calculated using standard enthalpy changes of formation. So now he's going to use Hess's law to get the delta H. Well, first of all, he's saying state why no delta H of formation has been given for oxygen. We do not have delta H of formation of elements because oxygen is an element in its standard state. You're not forming it from anything. So there is no delta H for elements in their standard state. Okay, he writes out the Hess's cycle, and you're supposed, first of all, to balance that equation on top, and you should know how to balance. We have 4 carbons before the arrow, so I need 4 carbons after the arrow. I have 10 hydrogens before the arrow, so I need 2 times 5 after the arrow, and that means I have after the arrow, I have 2 times 4 is 8 plus 5, 13. Well, I have already 1 in C4H10O, so I'm left with 12, so I need a 6. Basic balance. Okay, and then I need to fill out that box below. Remember that you're forming all of these from its elements. So which elements do I need? I need carbon, okay, so that is 4 carbons. I also need hydrogen. Now, how many hydrogens do I need? I need a total of 10 hydrogens, so that is 5H2. I also need oxygen. I need a total of 13 oxygens, so that is 2 times 6.5. And then if you want to complete it, the delta H that we want is the one on top. He gives me the delta H of formation for the C4H10O in the previous table. Remember that the numbers you have in the table are for 1 mole. So if I'm forming, for example, 4 CO2, then I have to multiply that number by 4. I'm forming 5 moles of water, so I have to multiply by 5. And then I can use this to calculate the delta H. Remember that going from minus 359 plus delta H will be equal to the other arrow. So from that you can calculate delta H. It comes out to be this number. Then he says the value for delta H obtained is much less exothermic than the one calculated. Remember that we always have, when we do this equation, the number is less than it should be. And he says, so just two reasons. Remember that you can either say it is because some of the heat was lost to the surroundings, or because there was incomplete combustion of the alcohol, or some of the alcohol evaporated, so the mass that we weighed is not actually correct. This question is about the elements in group 7. Use your knowledge of the trends in the properties of group 7 elements to predict the color and physical state of astatine. Remember that astatine is at the bottom of group 7, and we said as we go down, the boiling point increases, so the state goes from gas, liquid, solid, and the color gets darker. You have to remember that astatine is actually a black solid. Then he says, state the meaning of the term electronegativity. Do you remember the definition of electronegativity? It is the ability of an atom to attract the bonding pair of electrons in a covalent bond to itself. So explain the trend in electronegativity going down group 7. You have to remember, group 7 are the halogens. Going down the group, the electronegativity decreases. If we say which one is more electronegative, it is the fluorine, and then chlorine, and then bromine, and then iodine. And then we said, why is that? He says, explain. This is because as we go down the group, the element becomes bigger, so that the bonding pair of electrons will be further away from the positive nucleus, so it will be less attracted to the positive nucleus of the atoms, and that means that the electronegativity will decrease. So the elements become less electronegative going down the group. This is because the outer shell is further away from the positive nucleus, less attraction forces between the nucleus and the bonding electrons. Compare and contrast the reactions of chlorine with water, cold dilute aqueous alkali, hot concentrated aqueous alkali. Include an equation for each reaction, stating the type of reaction and the oxidation numbers of the chlorine involved. State symbols are not required. Remember, you are required to know these equations. These are all disproportionation reactions because, as you remember, the oxidation number of chlorine both increases and decreases. So the equation includes oxidation and reduction of chlorine. And this is the equation with water. We said it forms two acids, HCl and HOCl. Please learn these equations if you don't know them. You should remember that with cold dilute alkali, it forms KCl, water, and KClO, which is the potassium hypochlorite, and the oxidation number of chlorine in that is +1. With the hot concentrated KOH, it also forms KCl, but then it forms KClO3, which we call potassium chlorate. The chlorine in there is oxidation number +5. Magnesium ethanedioate decomposes on gentle heating to form magnesium carbonate and carbon monoxide. And the first question says, state why the thermal decomposition of magnesium ethanedioate should be carried out in a fume cover. Of course, if it is something that gives carbon monoxide, that's dangerous because carbon monoxide is a toxic gas. Then he says, this was the equation after heating a 6-gram sample of magnesium ethanedioate for 3 minutes. The decomposition was 70% complete. Now he's asking me to calculate what? The total mass of solid that remains. First of all, we can calculate how much he's supposed to get in this equation. So number of moles of the magnesium ethanedioate. He gives me 6 grams, so I can use mass over molecular mass to get the number of moles. And then you should know that the number of moles from the equation, number of moles of the reactant gives the same number of moles of magnesium carbonate. So I can calculate theoretically, if all of it reacts, I should end up with 4.5 grams of magnesium carbonate. But then he says not all of it reacts, only 70%. So 70% means instead of getting 4.5 grams of magnesium carbonate, I should get 3.15 grams. That's 70% of it. But then we haven't finished. He wants the total mass of solid. If only 70% of my initial compound reacted, that means I'm still left with some of that solid. Now, how much of that solid is remaining? It's 30% of the 6 grams are remaining. So I still have 1.8 grams of that magnesium ethanedioate, and that means the total mass of solid remaining is the sum of these two masses. Then he says magnesium carbonate undergoes thermal decomposition at a higher temperature than magnesium ethanedioate. Explain the trend in the thermal decomposition of group 2 carbonates going down the group. Okay, again, let's take a look. We said if we're looking at carbonates, carbonate itself is a big atomic group. And we said as we go down, the compound becomes more thermally stable. This is because going down the group, the radius of the metal ion increases with more shells, the charge density decreases, the polarizing power of the metal ion decreases, there will be less distortion of the electron cloud of the carbonate ion, weakening of the CO bond in the carbonate decreases, and the carbonate becomes more thermally stable as we go down the group. In this question, he says some diesel cars contain an extra catalytic converter for the reduction of nitrogen oxides in exhaust gases. A solution of urea is used for this process, and he gives you the structure of urea. He's telling me that urea has a melting temperature of 133 degrees Celsius. Explain why this value is higher than expected for a relatively small molecule. Remember, this depends on the kind of intermolecular forces that this molecule has. Well, let's look at this. First of all, it has a permanent dipole-dipole interaction. It also has hydrogen attached to an electronegative element, so it can form hydrogen bonds between the molecules. And of course, it has the weak London dispersion forces. Remember that the hydrogen bonds and permanent dipole-dipole interactions are stronger than any other molecule that does only weak London dispersion forces. A saturated solution of urea has a concentration of this. Calculate the mass of urea in 150 centimeter cubed. So of course we get the number of moles first in the solution. The number of moles would be concentration times volume. That is 1.36 mole. You need the mass. So the mass is number of moles times mR. The mass would be the number of moles that we get times the mR that we can calculate. Remember that he gave you the structure so you can calculate the mR, and that means the mass would be 81.6 grams. State why oxides of nitrogen emissions are harmful to the environment. Remember that oxides of nitrogen cause acid rain. Then this question talks about the infrared spectrum of urea, and he says, draw a circle around an absorption in the spectrum that could be due to the NH bond. Remember that you will have a data booklet that has all the wave numbers for all the different stretches, you should know that the NH is around the same area as the OH. So looking at the data booklet, you should realize that that would be the absorption for the NH bond. Then he says, identify the bond responsible for absorption at around 1700. Remember that around 1700, this is where the C double bond O peak is found. If you don't remember, then you can just check from the data booklet. You should be able to get it. Remember, keep in mind that we're still talking about urea, and from the structure that he gives me previously, he says that it has a C double bond O, so you would expect a peak at that area. In a diesel car exhaust system, the urea reacts with water to form ammonia and carbon dioxide, and the enthalpy change is plus 133. He says complete the equation for this reversible reaction. Some students would forget that if this is a reversible reaction, I have to put the sign for reversible reaction. And then he's telling me that it forms ammonia and carbon dioxide, and then I have to balance. Okay? Then he says sketch the reaction profile for the forward reaction. So notice that he gave me the delta H as a positive number, and that means this is an endothermic reaction. So remember that endothermic means the reactants took in energy and the products have more energy than the reactants. Where is the energy of activation in the delta H? Again, energy of activation is from reactants to the top. The delta H is from reactants to products. The catalytic converter contains metal oxides. When the exhaust gases pass through the catalytic converter, ammonia reacts with the oxides of nitrogen gases to form nitrogen and water. Explain why it is not correct to state that urea is a catalyst in this reaction. Well, if he says that it is reacting to forming new products, that means that it is not a catalyst. Urea reacts and is used up to form a new product. Remember, a catalyst is something that speeds up the reaction without being changed or without actually taking part in the reaction and changing into something else. Okay, then he says, explain how a catalyst increases the rate of the reaction. You have to remember that we said, what does the catalyst do? It lowers the activation energy. So if you have a certain activation energy, the molecules with energy higher than the activation energy are the ones that will have successful collisions. But with a catalyst, the energy of activation is lower. So all of these molecules with energy higher than this new activation energy will be able to have a successful collision, and that means you will have a faster reaction or more successful collisions per minute. So what the catalyst does is it lowers the energy of activation, so more molecules have energy higher than the energy of activation and more successful collisions per minute. The catalytic converter works best at a temperature of about 350. So just how the catalytic converter reaches this high temperature. Remember that the catalytic converter has gases coming from the engine, so these are hot gases due to the combustion of the fuel in the engine, so this will help to warm up the catalytic converter. This is the last part of the exam, the chemical reactions in the exhaust system of a diesel car using a catalytic converter form 89.3 meter cubed of nitrogen per hour. Calculate number of molecules. Remember, the number of molecules have to do with Avogadro's number. So in order to get this, we need to get the number of moles first. So the number of moles, please notice, usually we say the number of moles is volume over 24. But he's given me an information there that says molar volume at 350 degrees Celsius is 51.1. So it is not volume over 24. It is, remember that the 24 is the one at room temperature and pressure. But he's telling me that at 350, the molar volume is 51.1, so that means it is volume over 51.1. Remember that he gives me the volume in meter cubed. In order to put it in this equation, it has to be in decimeter cubed, and meter cubed you multiply by 1,000 to change it to decimeter cubed. So now you have the number of moles, and he wants the number of molecules. You should remember that the number of molecules is number of moles times Avogadro's constant. So that comes out with this number of molecules. Okay, that's the end of the exam. I hope that was useful to you. Please revise any parts that you feel you still need to study, and thank you for listening.